Good morning, everyone. Welcome, and thank you for joining us for today's FCICA webinar, Evolution of Wood Flooring Adhesives. This webinar will be recorded. The recorded session will be housed on the FCICA Member Center and this educational portal. Mark your calendars for these upcoming webinars. Thursday, February 11, join us for the Why, What, and How of Concrete Moisture Testing, presented by Jason Spangler, Flooring Division Sales Manager with Wagner Meters. On Thursday, February 18, join us for preparing the substrate and installation of flooring with EnviroStix polyacrylic adhesive, presented by Bill Weiss, National Technical Manager with Base King LLC. And on Thursday, February 25, join us for commercial flooring from planning to installation, a comprehensive review. Ortiz Bacon, Technical Services Manager, Littitz Flooring, and a Capri Collections Company. Visit FCICA to view and register for these webinars. FCICA has recently updated the safety book, Start with Safety. It is available electronically, free to members, and printed versions are available for $185. The safety book is an essential item to have in your office and on every job site. Purchase it on FCICA's website today. Again, welcome to the FCICA webinar series. We are pleased to have Sean Leahy, East Regional Sales Manager, Interior Finishing, and Andreas Eisenmann, Product Engineer for Sika Corporation, with us today. Presenter Sean Leahy has been in the flooring industry for over 2 decades, starting on the contractor side. Early positions as an estimator and project manager with a commercial contractor introduced him to the many installation methods, finished flooring products, and surface preparation scenarios. After 10 years on the contractor side, he moved to the manufacturer side, working for H.B. Fuller, primarily with Tec Installation, products, and Chapco Adhesives. As the East Regional Manager for Sika Interior Finishes, he leads the sales team, focusing on a full line of service prep products, flooring adhesives, and the new Sika Tile installation system. Presenter Andreas Eisenmann has been in the flooring industry for the past 6 years. Early positions as a marketing coordinator with the Sika Commercial Refurbishment, Sealing, and Bonding team introduced him to a wide range of construction projects. Andreas then moved into the interior finishing travel manufacturer's representative role, working directly with all U.S. floor and decor locations. Currently, he is the project engineer for the Sika Interior Finishes team, focusing on a full line of Sika MB, Sika Level surface preparation products, Sika Bond, flooring adhesives, and the brand new Sika Tile and stone installation product range. Welcome, Sean and Andreas. We're excited to have you. I'm going to turn the controls over to you.
Thank you, and good afternoon, everyone, and good morning to our friends on the West Coast. My name is Sean Leahy, and I'll be going through the presentation today. And at the end, we'll definitely have a question and answer session, and Dre and I will be available to answer any questions that you have on the presentation or wood flooring installation in general. So the title of today's webinar is Elastic Bonding for Wood Flooring. So we'll get into the little bit of the chemistry behind it and why it's done and really how it's become sort of the preferred method of installing wood moving forward today. So through the course, some of the objectives that we're looking to go over is an overall overview of the installation of wood flooring, the substrates, how moisture can affect it, different types of adhesives, elastic versus rigid. We'll get into more in depth about the different components of elastic bonding for wood flooring. We'll talk about sound reduction, which has become more and more important with the multifamily construction that's going on. We'll talk about some next generation systems. We'll wrap it up with some of the ecology, which is really the VOCs surrounding these types of products. And then we will go from there. So wood flooring, it's obviously it's a timeless product. It's traditionally been used mostly residentially. For the most part, hardwood, engineered or solid, does not hold up fantastic in a commercial atmosphere, but in some office application, wood is used and specified. But for the most part, we know the majority of wood is installed residentially. Houses with wood floors are usually desirable, increases the value of the house, and it's a very popular type of item when someone is looking to do any kind of refinish within their house or rehab their house, replace carpeting, replace vinyl. Wood is right up there as one of the top sellers in that type of application. Several traditional ways of installing hardwood floors. Obviously, when it first came out, mechanical fastening was the traditional method of putting down hardwood. It would either be nailed or cleated or stapled. They did not have the glues that we have today. They did not have the technology with the glues that we have today. So everything was a mechanical fastening. While it did the job, it did have some drawbacks. There was a higher risk of joints and gapping, which we'll get into. A lot of noises and squeaky wood, and that is a result of the actual mechanical fastener getting loose within the wood and shimmying up and vibrating and creating that type of noise. And it's labor intensive. You're standing for the most part, bending over, hammering these nails or cleats into the wood. So there is some intense labor associated with installing hardwood in the traditional mechanical fastening method. So the early part of quote-unquote gluing down wood was this bituminous type of an application where they actually used hot tar to set the wood in place. It was a poor fixing method. The wood would eventually shimmy loose because the tar doesn't have a whole lot of grab and adhesion properties to it. It more or less set the wood in place. And eventually from just repeated walking and foot traffic and things sliding across it, those pieces would eventually shimmy loose and you would start getting loose boards in your installation. Tar, we know, has a very high odor. It's difficult to clean up. There's health concerns with it. So this type of application early on for gluing down wood versus nailing down became very difficult. And a lot of times they would use this method really to set their sleeper systems to eventually just come back and nail down anyway. So the early stages of glue down, this tar method that was used, the hot bitumen, was rather difficult to manage, let's say. Oops, I think I went one too many there. Yeah, okay. Then they moved into some rigid adhesives for full surface bonding. These were typically two-component products. So you'd have two-component urethanes or two-component epoxies that would go down as a adhesive, but they would cure out very rigid. They had very short pot lives. You had to mix it quickly, use it quickly. Otherwise, you had an excessive amount of waste on the job. For the most part, they were solvent-based, so you had a very strong smell. You had flammable components which made the products difficult to ship and difficult to get onto job sites. And then you had these dispersion powder adhesives that had very high water content, which did a good job of adhering the product, but because of the water content, it caused all kinds of nightmares for the flooring installer and the homeowner or business owner when that moisture would eventually work its way into the wood. And we'll get into that in a little bit. Keeps going too. And then we got into, in 1994, the new concept of using an elastic wood flooring adhesive. The innovation of elastic wood flooring bonding changed the way of thinking for the professional installer, and the industry standards adapted to this new concept. So once these types of products came out, it took a little while for the industry to really accept them. It was something that was against the norm. They had been working with rigid adhesives up until that point, and there was some concerns about using something that had so much flexibility as these elastic wood flooring adhesives. But as you'll see here in some of the slides coming up, there's reasons why that's a better application in the long run as compared to rigid. So obviously elastic bonding has a very long history in the construction and industrial climate that's been out there. It's not just in flooring. You can see it across the construction industry, where they use it in all different applications for sealants and window glazing and railing applications, where they want to have some type of movement be allowed and almost promoted as compared to a rigid adhesive. So some companies have as much as 25 years experience with this type of application. Elastic technology gets used often in vehicles and boats. The reason for that is it handles change of temperature very well, whereas some other types of adhesives cannot handle freeze thaws and the continuous cycles that you have over and over again throughout the lifespan of an installation. Elastic adhesives are able to do that. They're able to maintain permanent elasticity, which in something like a car, which has all that constant vibration, something like a boat that is constantly exposed to rain, snow, sleet, salt water. These types of adhesives stand up in those kinds of applications, which in turn make them very successful when you look at wood installs. Elastic technology has been used in construction for panel systems and wood systems and all types of sealants that will promote a successful building enclosure. So these types of adhesives have been used in the building industry for years, and they do a very good job of bonding and sealing and flexing and allowing the products that they are adhered to flex and not break free, which is why you see it in things like window panels. It's proven successful indoor and outdoor, which I mentioned, and they found an early use for it installing wood over top of ceramic tiles. They found that it was able to bond to even a non-porous substrate, which made it very attractive when looking to change the look of a house or change the look of a commercial space and not have to go through the demo of ripping out existing tile. So when you look at the elastic bonding and the different types of bonding systems that are out there, it gets broken down into a couple different categories. You have your full surface bonding, which is a trowelable adhesive, where the entire floor gets coated with the adhesive, the particular adhesive that the installer is using, and then the wood gets laid into it. You have several different types of acoustic systems out there. You have mats that the adhesive is used in slots. You have mats where the adhesive is used underneath and then on top of the mat. So the introduction of these types of acoustical systems to create sound reduction has also led to the increase of the use of elastic bonding in the wood flooring industry. The cordon or the serpentine method has also increased the use of adhesives on jobs. It's become very much more design oriented and popular to use wider plank flooring. And if you know anything about installing wood flooring, once you get past about 5 inches of width, you want to have some type of an additional mechanism to adhere the floor, not just a mechanical nail or a brad or a staple. It will not hold a 5-inch or wider board with the amount of movement that occurs. So what they do to promote a successful installation is they'll incorporate adhesive in either the cordon or the serpentine method. That picture there shows the cordon, where they basically just put rows of the adhesive about 6 inches apart, lay the wood into it, and then nail it into the subfloor. Serpentine would be where they put sort of an S-shaped design on the bottom of the wood floor before they set it into place and nail it. But the cordon and serpentine is a great glue assist method when you get boards wider than 5 inches. And of course, with the introduction of a lot of these moisture mitigation products that are out there in the market, and also substrate consolidation, when you have someone who wants to put wood flooring over top of something like a gypcrete that does not have the compressive strength required by NWFA to glue to it, you have an influx of these types of products into the market that will consolidate the substrate, reduce the moisture, but now you're left with a surface that is typically non-porous because most of these products are epoxy based. So the elastic bonding that's used in these wood flooring products, the urethane adhesives, will bond directly to these substrate consolidators / moisture mitigation systems that are becoming more and more prevalent in the market today. Some basics behind wood floor bonding. Obviously, we get right into the types of wood flooring that's out there that we're being asked to glue down. You have solid wood floors. Everyone knows what that is pretty much. That's your 3/4 inch planks that are out there in the market of all different types of species. They have a tongue and groove. These are the products that traditionally have always been mechanically fastened with nails, staples, things of that nature, going directly through the tongue and into the substrate. Engineered floors were created to lessen the effect of expansion and contraction. These products are typically more dimensionally stable than a solid. And the reason for that is they're anywhere between 2 to 8 plies of wood that are laid perpendicular to one another, glued in between, and then the finished product is on top. That's what gives you the visual, the oak or the mahogany or whatever species that you have as the engineered wood. That's your top layer. These products are great. They provide the dimensional stability, so there's typically a lot less movement, so you have less gapping when you use products like this. The negative to it is the lifespan. You're not able typically to sand and refinish these types of products as often as you can a solid hardwood, because they are just thinner products, not only by nature, but also the final veneer or the finished visual species that you have on your floor is a very thin layer. So you aren't able to sand and refinish it as often as you can a solid hardwood. All wood contains moisture. That's why you need to acclimate your wood before it gets installed. So typically an installer will bring it into the house and let it sit there for 3 or 4 days so that it acclimates and it matches the relative humidity to the house, so that once it's installed, you don't get any severe expansion or contraction. But water by nature can wreak havoc on a wood install. There's 2 types of water that is present in wood. You have free water and bound water. The free water is contained in the cell cavities. It's not held by these forces, so it's sort of like water that you would have in a pipe. The bound water is held within the cell walls by physical or chemical forces, and that water remains in the cell walls, and that's the type of water that's affected by the exterior humidity or the temperature that causes the expansion and contraction in wood once it's laid down in place. The wood can change dimension as it gains or loses moisture. That's where you hear about your wood shrinking or your wood swelling. You get your cupping that you hear a lot, face checking, gaps in your strip flooring that are become unattractive. All of that is caused by the water that's in the hardwood, allowing that wood to expand and contract. The one thing that people forget is when that wood is on your floor, it is still a living, breathing plant, essentially. That is, it's taking in water, it's releasing water, it's constantly moving. And we've gotten better with these adhesives in minimizing the risk that movement causes to the install. But it's important to understand why they happen. It's important to understand to the homeowner, hey, if you're going to leave your house for the winter, you have to maintain a certain temperature in that house if you have hardwood flooring. If you're leaving your house in the summer, you have to keep the air conditioning on. If you want to maintain the appearance of your flooring, you have to maintain that humidity level, or else it can wreak havoc on the appearance of your hardwood floor. So shrinking and swelling, that's really what the issue rises with wood installs and what can create the issues. Wood shrinks mostly in the direction of the annual growth rings, about half as much across the rings and only a little bit across the grain. So if you're looking at your hardwood and the type of product that you have, if you see a lot of those growth rings, that's where you're going to get the most shrinkage and you're going to get the most movement in your flooring. The combined effects of these shrinkage can cause distortion in the shape of the wood, and that's what can cause the cupping. It can cause the face checking, and it can cause the gapping at your joints where your 2 pieces of wood meet. And ultimately, if it becomes bad enough, it can cause the wood to buckle, and we've seen that all over the place where the floor looks fine, but then you get to a part of the floor and 2 or 3 boards have literally buckled and peaked straight up. That's the worst case scenario that you can get when you get this type of movement in your wood floor. And that can be caused by a number of things, not necessarily how how it's fastened to the floor. If the installer did not leave enough gap around the perimeter and he's butted right up against his drywall or metal studs, that wood's got nowhere to go and it will eventually buckle up. But it's important to remember that this shrinking and swelling is a natural function of having a hardwood floor. Moisture content and the strength and evenness, or the compressive strength of substrate, should always be within the guidelines of NWFA and the wood flooring manufacturers. That's the first thing installers should be checking. What's the moisture content of the floor I'm going over top of? And how strong is it? What's the compressive strength? There is a minimum number that you have to hit in order for NWFA to say, yeah, you can go ahead and glue that down. Factors of wood floor bonding. So there's a number of factors really that installers look for in their adhesive when they're trying to decide what they want to use to bond their wood floor. They want that tack-free time. They're looking for, like, how much time do I have once I spread my adhesive till I need to get into it? Because obviously with this type of adhesive, once it skins over, it's dead. You can't reactivate it. You can't sort of run your trowel through it and get it sort of loosened up again, like sometimes you can with a ceramic thin set. Once this product starts to skim over, it's done and needs to be scraped off, and you need to put down new product. So installers will look for a product that has a nice open time. They also want green strength. Green strength is the strength development of the adhesive at an early stage. And why is that important for a wood install is, like we mentioned, this wood is a natural living, breathing product, and sometimes you'll open up a case of plank and you'll start laying it down and everything is nice and flat and perfect, and you'll go to open the next case and you have a couple products or a couple planks in it that have crowned and there's a high spot in the middle. Well, if you need all that product and you need to get all that product down, it's important that the green strength is good, because that will actually hold that crown down flat against the substrate and not allow it to pop up. If you have a product that does not have very good green strength, even when you press it down into the adhesives and flatten the ridges out, it will still pop up because the wood wants to pull away because of that crown in the middle. And that's when you'll see installers out there with weights, or they'll use full buckets of adhesive to weigh down parts of the floor that are popping up. That's because the product does not have very good green strength. So that's an important factor to look at when you're picking your wood adhesive. Also, the curing rate. How fast does the product cure? The majority of these products that are out there are moisture cured urethanes, so they actually cure by absorbing water. So that cure rate can be dictated by a number of things. What's the humidity in the house? What's the humidity outside? Has it recently rained? Has the wood properly acclimated? So there's a number of things that can affect that cure rate, but typically the number on the data sheet is fairly accurate. And the installers want a cure rate that's pretty fast, especially if they're using unfinished hardwood. If they're gluing down a hardwood that's not finished yet, they want that cure rate to be faster, because that speeds up the time they can get on top of it with their sanding machines, get it primed and ready for them to put down their stain and their urethane coatings. So that's what they look for in the curing rate. The viscosity is also very important to the installer. They want lower viscosity products because it's easier to spread. You'll hear the guys joke that certain products give them Popeye arms. Urethane by nature is a fairly stiff product as compared to some of the other adhesives that guys might use in the market. If you have a guy who's used to spreading VCT glue all day long, and then you give him a bucket of urethane, you're not going to be his best friend. But that being said, within the market of urethane adhesives, there are products out there that have lower viscosities, that are easier to spread, and some that are much more difficult. So these are the four things that contractors will typically gravitate towards when they go to pick out their wood flooring adhesive. Other factors that are important. Sure, that's the hardness of the sealants. That's required for tongue and groove applications. They look for tensile strength. Tensile strength is where you get your cohesion failure. Cohesion failure is very important, and we'll get into that a little bit later, but cohesion failure is a failure within the middle of the adhesive, in the body of the adhesive. So it's not an adhesion failure, it's a cohesion failure. And we'll get into why that's important in a little bit. The elongation at the breaking point, that's important because elongation shows a high recovery. And what that means is that when your wood expands and contracts, the adhesive is going to allow it to do that and constantly allow it to come back to its normal state. What that does is it minimizes or negates the chances of any kind of gapping taking place where your planks meet one another. The laying techniques as they put this adhesive down and as they install flooring. As we talked about earlier, the initial method of laying down hardwood was mechanical fixing or mechanical fastening. It's nailed down into the subfloor, which is typically plywood, which is laid over top of joists. It's easy to remove. If you do have a hardwood floor that's nailed down, once you get a corner up or an area up and you get a crowbar into it, the boards pop up fairly easily. If you have the proper equipment, it's an easy install. You have a nail gun and a pair of knee pads, and you're off and running. The tolerance of distorted wood is also much higher in the mechanical fixing. What that means is, and you see in parentheses there, it's forced. It's because you can get boards that have bows or skews in it, and a skew would be where the end of the board, the tail end or the head end, flails out. It's not level with the rest of the board, and you have to mechanically pull that back in and hold it in place and apply the nail. That's why many installers like the nail down methods, because you can enforce a misshaped board into place with nails. The negatives, high audible level, they're noisy, they're squeaky. The reason for that is when you nail a board down, that nail creates a hole in the wood. That's fine. The problem is over constant repeated footfalls and rolling traffic and dogs running up and down across it, the weight and the compression down onto that board causes that nail to move a little bit. And every time it moves, it makes that hole that the nail sits in a little bit larger. And then it moves again, it becomes a little bit larger and a little bit larger. And that's where you get your squeaking from, is actually the nail moving within the board and creating that larger hole. And it's no longer a nice tight seal. Low quality of fixation, there's risk of joints and gaps because the nails, while they hold it in place initially, they don't do a very good job of holding it when it expands and contracts. It's not state-of-the-art, and in the sense that it's a very old application. And there's a raised threshold. You need a higher buildup. So whatever type of flooring you're installing, whatever type of nail you're using, you need to make sure that the buildup will accept it. Not so much with the deflection, which we know is important, and you need a minimum thickness of a subfloor when you have deflection, but just the overall process of installing hardwood via nail down requires a thicker substrate. The other method is the floating system, which has become more popular, or the lock in place. Parquet wooden panels laid without any kind of mechanical or adhesion. Typically, these are low-cost products. They have a low transmission of impact sound, which means sound going down. So if you live below someone who has a floating floor, typically you don't hear it as much. Easy application, a lot of do-it-yourself products that are out there in the market at big box stores is this type of a system. And there's not a whole lot of need for substrate preparation. If you have existing adhesive down, you can pretty much go right over top of it. If you have existing vinyl tile down, you can typically lay a sheet for some sound deadening and go right over top of the existing tile. So there's not a whole lot of substrate preparation involved when you have a floating system. Some of the negatives, it has a high reflective noise. So that's the difference. The impact noise would be someone living below you. The reflective noise is actually you living in the living space yourself. So it's a higher noise in these types of systems that you're dealing with as compared to your neighbors below you. There's also a trampoline effect. If this floor is not properly installed and you don't have proper gapping around the perimeter, I talked earlier about how nail down or glue down woods will buckle. These types of systems, you get a trampoline effect. You almost get sort of a bubble in the middle of the room, and it causes a bounce in the floor. You'll also get that if you don't have a nice level floor. If you're doing this over top of a concrete slab and it has like a bird bath in the middle or a crown at the top, you'll get the same effect if it's not properly treated with a self-leveler. You do have risk of joint gap formation. That's typically a breakdown of the click system. Over time, just people dragging their feet or kicking the sides of it, you'll get some gappage within your laminate, your floating system. And you can't really resand or rework these products. They're floating, they're not adhered down. So trying to put a belt sander over top of this product or a drum sander, the whole floor just wants to move around. It's not fixed to anything. The elastic bonding system. This has become the most popular system out there, really, to bond hardwood flooring or to install hardwood flooring. It's the most well-bonded application because you do get full spread on the adhesives. You don't have any squeaking because there's no nails in the system. So that's something important that, to stress to the end user or the homeowner. If you have concerns about having a squeaky hardwood floor, the adhesives remove the nails, remove the source of that squeaking 100%. Some of these products can provide moisture protection. Some of them can provide sound protection. It allows for the expansion and contraction of planks. That's an elongation that we talked about earlier. It allows the wood to expand and then contract back. You're able to apply on concrete and plywood. So for years, wood was only a product that you could install with a plywood substrate. If you had a house that was a rancher and had a concrete slab floor, wood was sort of off the table for you. This type of a product, and the full spread adhesion, puts that back on the possibility of a designer being able to put hardwood flooring in those types of application. Some of the downsides of adhesion, it's definitely more costly than nails. If you've ever bought a pail of wood glue, it's not inexpensive. They are expensive products because of the urethane that they're made of. They can be messy. These moisture-cured urethanes, if they get on something, they're difficult to get off. Typically, you need mineral spirits or a solvent-type cleaner to remove it off of tools or your hands if it started to cure out. But it also does cause some issues with pre-finished hardwood. So I talked earlier about how installers like to use adhesives with a fast cure rate if they're putting down unfinished hardwood. But if you're putting down finished, this type of a scenario can create some issues if that urethane gets on the surface of the finished hardwood. It can etch or ghost the surface, even if you clean it up and the adhesive is no longer visibly there. The haze of it or the ghosting of it that has affected the finish stays behind. So that can cause some issues. Guys have to go out and replace some boards sometimes if they've left adhesive on it too long. The application is intensive. You're down on your hands and knees with a trowel spreading it. You can only do so many square feet at a time because, again, you got to worry about that setup time. You don't want it flashing over or skinning over on you. And there are substrate prep needs. You do want a flat floor when you do this type of an installation. You don't want any high spots that'll cause the board to lift up and out of the adhesive. You don't want any low spots where you're asking the board to bend and stay in the adhesive bed. So you want a nice flat floor when you do a glue down installation. We'll get into the surface preparation a little bit. Generally, if it's over top of concrete, you want to rough it up a little bit. You want to sand and get any contaminants that are off of it. Vacuum up any dust or loose particles. If there's any kind of paint or spackle that's on the floor, you want to make sure all that comes up. You want to make sure you're going over top of clean substrate. You don't want anything there to be any kind of bond breaker. Some other issues that you could run into with a substrate, obviously, if the substrate is not strong enough to handle the adhesive, that's when you need a consolidator. If there's substances on there that are weaker than a concrete, you need to get them off. That's what I mentioned, the spackle that might be left behind or paint. All that has a much weaker tensile strength, and that will get pulled off by an adhesive as it cures out. And then we'll get called, and you'll have wood popping up, and the adhesive manufacturer will go out there and take a look at it and look at the bottom of the wood, and the adhesive has come clean off the surface. And then on the cured underneath of the board, embedded in the adhesive is paint and spackle, construction debris, dust. So you have to make sure all of that is up and off before you put down your glue. Softening agents, yeah, I mean, you've heard of plasticizer migration with carpet tile adhesives and things of that nature. It's the same thing with this. Any kind of old adhesives that are down can wreak havoc on a new adhesive laid over top of it. So you want to make sure you get all the old adhesive up if you're looking to bond directly to it with a wood adhesive. And then you got to ask yourself, do I need substrate preparation? Do I need to level this floor? Do I need to patch it? Do I need to get rid of some of these low spots? All of that will create a better install if they're addressed properly in the beginning. Some of the issues guys deal with out on job sites: excessive moisture, poor strength. I mean, even a concrete slab, if it's not treated properly during the troweling phase, if it's over troweled and all that water comes to the surface, you can create a very weak top layer of your concrete that you can take a pen or a key or the claw side of a hammer and just dig right into. If you have that condition out of the job site, you do not have the compressive strength needed for a wood glue to properly work. That doesn't mean the job is done. It doesn't mean anything's got to get ripped out, but you do have to find some type of a substrate consolidator to go over top of that to get the compressive strength back within the range needed by NWFA to use a glue. And then the last one, obviously, is adhesive residue. That is a huge issue with wood flooring. That's a big bond breaker, has to be addressed. You have to get that adhesive up, because if that adhesive were to release, you've heard all types of adhesive and thin set manufacturers say the same thing. We're only as good as what we bond to. So an adhesive will bond to that residue that's left behind, but if for whatever reason that residue decides to lift from the concrete, everything that's attached to it is going to lift as well. So you need to make sure that's addressed before you do any kind of a glue down application with wood. Moisture, that's a huge issue with wood. It comes from three sources. It can be residual moisture in a self-leveler that you might have used. It can be moisture coming up from the original concrete slab that just is not done off-gassing yet. Or you could have a wet slab. You could have water from the water table penetrating. That's where you don't have a properly installed moisture vapor barrier. And that's a huge issue as well. All three of these sources of moisture, though, can adversely affect a wood install. You get cupping, you get crowning. Everyone has seen that middle picture, maybe in their own house or a friend's house, where you have the light shining in from a window and it just looks like a set of piano keys, because there's all kinds of irregularities on the edges of that wood that distorts the image of the light coming through. And in worst case scenarios, you get a debonding or a buckling of the hardwood where it actually lifts up and off the substrate. That moisture has got to go somewhere, and it's going to find a way. So there are solutions for it, obviously, that can address it. And typically those types of solutions can address a number of issues. They can address if the slab is too high with moisture content. It can address if the slab is too high with moisture, but you can't wait for it to finish off, releasing all of its moisture. If there's time pressure on the schedule to get a job done. If the substrate is not strong enough, you saw that picture earlier, if you can rub a key through it and scratch it and powder it up. And then also if you have old adhesives that you need to go over top of. All four of these scenarios can typically be remedied with a moisture mitigator / substrate consolidator. So the moisture system, there's products out there that can handle up to 6% on the tray mix, 100% relative humidity, 25 pounds on calcium chloride. It can reduce the construction period. So when a GC is looking to save days off of his schedule, and you're the flooring installer and you're telling him you can't come in because moisture levels are too high, there's products out there that can solve that. They're fast and simple. Typically they're roll-on products, not very hard to put down. Adhesion promoter. Again, if you have if you're doing a rehab type project and you have existing adhesives down there, there are some of these substrate consolidators / moisture mitigators that are out there where you only have to get 50% of that old adhesive up. There's many that require you to get 100% of the adhesive up, but there's one in particular that you only need to get 50% of the adhesive up. So that can save a lot of time on a job site. You don't have to bring in a bead blaster, shot blaster to get all of that adhesive off. You can typically get 50% off with a very good scrape or a sanding or scarifying type of a situation. But it will consolidate gypsum-based substrates, so that's key. There's not many gypsum systems out there that, when they're finally cured, have the compressive strength required for a glue down application. But a consolidator put over top of it will give you that compressive strength. Also, using those types of products will actually decrease the consumption of your wood adhesive. You'll get more out of a bucket when you go over top of it with one of these products. Typically, they take 8 hours to cure, and they're usually epoxy, two-part epoxies that are used to control the moisture in a slab or consolidated. If you're looking to do both, moisture mitigation and consolidation, most products will ask you to do 2 coats. So a lot of this is what we talked about earlier. What is cohesion? What is adhesion? But again, these are all the different things that installers look for, important properties for their adhesive that they're looking for. Workability, the grain strength, how fast does it cure, what's my tensile strength, and does it have good elongation? Is it going to expand and contract with the wood? So adhesion must be stronger than cohesion. What that means is if there's going to be a failure, you want the failure in the middle of the adhesive. That requires an excessive amount of force and torque typically to cause a cohesion failure. But if that fails and not the adhesion, that's good, because then you don't have the wood releasing from the adhesive and you don't have the adhesive releasing from the substrate. So you want a very strong adhesion. And if there is going to be a failure, you look for it in the middle of the adhesive. Types of adhesion, you can have all combinations, but there's form locking, there's intermolecular locking, there's chemical locking, but they all do the same thing. They adhere component A to component B. Rigid versus elastic. Rigid, that bolt that's set in place there in that anchor, it's not going to move. And you have a rigid adhesive keeping it in place, and it's load bearing. The elastic adhesive, they're able to absorb movement. And here they give you an example of a rail. And sometimes you want that rail and the adhesive that's being used to affix it in place, you want there to be a little bit of movement there. If you think about a lot of these stadiums that have glass panels as railings or glass panels as dividers, they're set into a flexible adhesive into the floor, and they want that to move a little bit. If it's rigid, if someone bumps into it, the glass shatters. But if it's got a little bit of flex to it and move, it allows for that without breaking whatever's being adhered into it. So that's why you have the 2 different types of adhesives out there in the market. Wood flooring is always going to be the elastic version. This talks a little bit about why elastic versus rigid. You want the movement to take place. And then after it takes place, you see there in the elastic, you want it to bounce back. Whereas with plastic, you get that movement or that compression and it stays low, essentially. So the idea of having the elastic is you get the pressure or the stress point and it bounces back to where it was originally at. In case of adhesive deformation, the volume of the adhesive stays the same. So even when you have compression or shearing or peeling or any kind of movement within the board, the volume of your adhesive stays the same. It's always going to snap back to its original state, and that's what you want in wood floor bonding. That prevents your gapping and any kind of cupping, because the adhesive that's put in place, no matter where it moves, it's always going to snap back to its original state. This shows the curing of the adhesive. These adhesives, as I stated earlier, they're moisture curing. So they're going to pull moisture from the wood, and they're going to pull moisture from the substrate. So the top and the bottom are going to start to cure first, and then it'll slowly move down to the middle before the entire sandwich there is cured out. This is a couple interesting slides that show stress distribution. It shows first a rigid adhesive. You can see the stress distribution is primarily on 2 spots, left and right of the board. When you have a riveted or a nailed application, all the stress is right there at the nail. Every kind of movement, any kind of stress, shearing or otherwise, occurs right there at that nail. That's why those holes that the nail are in get larger and larger, and that's how you get all the squeaking. With an elastic adhesive, the stress is displaced throughout the entire board uniformly. And that's very important because that's what keeps the board in place year after year, season after season of it expanding and contraction, because the stress is distributed uniformly, you don't get any kind of buckling. This just shows it, different applications and how the stress can, by temperature, can affect all different types of applications. Where you have a mechanical fastening, you see a bow. Where you have rigid application, it stays in the middle, but the ends flare out. And with elastic, everything stays the same because the elastic allows it to move and snap back. And they do that with a plastic panel in the sun. Exposure to different cycles. Again, we don't have a floor down just for one winter, for 20 winters, 30 winters. It's going to experience that expansion and contraction over and over and over again throughout the year and every single year. So you need an adhesive that's going to be able to handle that constant stretching over and over, and that's why you need an elastic. A rigid, once it breaks once, it's done. Like that gap that you see there on the left, that will never close because the adhesive is rigid. Again, you also get much more instances of buckling with rigid adhesive because the force has nowhere to go. It can't be distributed like it can in an elastic adhesive. Sound reduction. All different types of application. There's full surface or full spread adhesives that give you sound reduction. You can get it from some of the cordon or serpentine adhesives that are out there. Obviously, we have the acoustical systems. And we talked about the floating systems a little bit earlier. This is interesting. That shows the dispersion of sound based off the installation method. So rigid bonding does a very good job of keeping sound out of the room that you're in, but it wreaks havoc on whoever's living below you. Elastic bonding is pretty good. It disperses it a little bit above and a little bit below. Same with the cordon. When you get into the acoustical systems that have adhesives that are specifically designed to prevent sound, you get much less transferring down below to your neighbors below you. And then the floating system, that has a very high airborne sound. So if you're actually living in the house that has the floating system, you're experiencing the noise much more than someone living below you. This is just a quick slide to show the sound reduction and what's used to test it, and the different categories they have of testing methods and where they want to try and be for the ASTM standard of 50. They put this machine down that drums on the floor, and then they have microphones spaced throughout the room, but then also below the room to get the noise that gets transferred below. Some alternatives to noise, foam backed wood floor. You've seen wood floor that actually has a foam backing. Foam underlayments, cork underlayments, recycled rubber underlayments that are double stick type applications, and then floating underlayments as well. All of these types of applications are designed to decrease the amount of sound transferred with a wood flooring install. Next generation wood flooring. All-in-one adhesives have become extremely popular. Very easy to apply. They're basically, for the most part, depending on the product, they can actually be hybrids, so they're not full 100% urethanes. They're some type of a hybrid, and that gives it a lot more workability, so the installers like it because there's less strain on their forearms. They've developed these all-in-one adhesives to be able to bond solid and engineered hardwood directly to concrete. They have permanent elasticity, which is important because we know that this wood will continue to expand and contract through the life of the floor. They're fast curing, these all-in-ones. You can get on them in 18 hours and start sanding, which is good for this type of an application. They offer footfall sound control. So when they talk about all-in-one, they're talking about not just bonding the wood to the substrate, but also supplying sound control and then moisture vapor protection. For the most part, these products are easy to clean, especially the hybrids. I talked earlier about how if a urethane gets onto a pre-finished wood, it can really cause some damage to the finish. These hybrid all-in-one adhesives, they do not cause that kind of damage. You can leave that adhesive on there for days, even weeks, and come back and take it off with a credit card, and you will see no hazing, you'll see no ghosting of the finish. So guys that do a lot of pre-finished work are really starting to gravitate towards these hybrid all-in-one adhesives. They can be used for double stick applications, can be used over radiant heat. So they can do everything that you can do with a normal urethane adhesive. But sometimes some aspects of the install, they can actually do a little bit better. You see some of the technology out there has better elongation, better tensile strength, and you're already exhibiting elastic properties up to 12 hours. And with some of the older urethane adhesives out there, they're still curing out at 12 hours. There's acoustical systems that are out there. Again, this particular one has a gun with an adhesive that's used in conjunction with a foam. There's other ones out there that are just the foam and peel and stick type applications. But what they typically do is they provide the STC ratings needed. So it surpasses the BOCA and the NWFA specs of 45 STC. And with some of these applications, you can use it to install solid wood up to 8 inches wide, and engineered wood up to 14 inches wide. There's actually some applications and some systems out there where the engineered wood is unlimited. But you can bond all different types of products using this type of an application. And the adhesive that you use is permanently elastic, so it's going to be able to handle the constant expanding and contracting. Getting towards the end here, we get a little bit into the ecology of it, particularly on the VOCs. That's really, really important nowadays in the construction industry, is how much VOCs do your products have. Urethanes by nature are low VOCs, but they're not zero VOCs. So if you have a product that claims to be zero VOCs, that's not a urethane. It's probably one of the hybrids or a silane-based product that has zero VOCs. But the hardwood, the urethane, moisture-cured urethanes that are out there do typically have some VOCs in it, although for the most part they're less than 100 grams. So they're within the limits to have out there for an installation. Obviously, the lower the VOC, the better the air quality. But do not confuse odorless with being low VOC. You can still have an odorless product that is high VOCs. But just wanted to touch on that here towards the end. Finally, in conclusion, the elastic adhesives have become the most suitable products for bonding wood floors. The pros for it, obviously, it's stronger than mechanical fastening, longer term solution that solves the common issues that are out there in the market. Uniform stress distribution, which is huge. Any kind of stress or expansion contraction is uniformly dispersed across the install, so you don't have the buckling, you don't have the swelling, you don't have the noise and the creakiness from the nails getting loose. Minimizes joints and gaps. You can go large surfaces without needing movement joints because the adhesive is going to handle the movement for you. Compensation of small substrate unevenness and sound dampening. So overall, it's a higher quality solution, a higher quality install, and less callbacks when you use adhesive versus a mechanical fastening. That is our presentation for today. Happy to open it up to any questions that are out there and see what we can do to help you out with any questions regarding wood installs or wood adhesives.
Great. Thank you so much, Sean. If the questions or comments, please submit them in the question box on the left side of your screen. We'll wait a moment for people to enter in their questions. Okay, we have one question here. And that first question is, how do all-in-one adhesives limit moisture-related issues? Okay, so for the all-in-one adhesives, for the most part, the way that they limit moisture, and they do this in a number of different ways, but they put down a uniform amount of adhesive that creates 100% coverage on the substrate and 100% coverage on the back of the wood. In fact, the picture here that showed the last picture, the last slide here of the presentation, that shows a good example of a uniform layer of adhesive that's being laid down. And even when the wood is pressed into it, you see maybe every 4 or 5 inches there, you can see the substrate through the trowel marks.
that'll collapse once the wood is pressed into it, and it creates a layer, a uniform layer of urethane underneath it. That will stop moisture. And the different products that are out there, they achieve that in different ways. Some of them achieve it in a trowel, like they'll give you a specific trowel with the adhesive that actually lifts the teeth off of the substrate so that you're still leaving behind ridges, but you're also leaving behind a thin layer of urethane. There's other companies out there that put like small recycled pellets, rubber pellets in the adhesive. And what that does is you can then use a standard trowel, but because those pellets are in place, it lifts, the pellets lift the trowel up, and that provides the uniform urethane adhesive. But that's how you get your moisture protection, is really just a solid layer of adhesive, versus if you were to use a regular trowel with this type of application, you would not ensure 100% coverage of the substrate and 100% coverage of the back of the board. That's how you get the moisture protection.
Okay, great. We have another question, and that question is, when should installers use the glue-assisted method? Yeah,
we touched on that a little bit earlier. So it's recommended that anytime you're installing a solid wood floor that is 5 inches or wider, and we've seen wood plank come out that's 8, 10, 12, 14 inches wide of solid wood. You cannot expect that a nail pattern will keep that in place all by itself. So anything 5 inches or wider on the solid variety where you are going to nail it down, we do recommend that you glue assist. And there's guys that use adhesive that comes in sausages to do that, to do the cordon method or the serpentine method. We have guys that will actually do full spread adhesive, put the wood into it, and then nail. That's fine also. But anything 5 inches or wider, you want to apply a second method of fixation with the glue down.
Okay, we have another question that is, can just engineered wood be glued down?
No, so the technology in these wood adhesives has advanced to the point now where they can handle 3/4 inch solid being glued down directly to concrete or plywood. So this is not just a product that you need to use with engineered. It can now be used with solid hardwood product that typically would be nailed down. You can use these types of adhesive, 100% coverage, and take the nails out of the equation.
Okay, we have time for just one more question, and that is, what is put in adhesives to make it have sound control?
So that can be accomplished a number of ways. I mentioned before how there's some manufacturers that actually put like a very, very tiny rubber pellets in the adhesive that not only help lift the trowel up to give it the moisture protection, but those rubber pellets also provide some sound protection. And then it's also companies out there that use a much higher quality of urethane. When you have a higher quality of urethane, there's no fillers in it. And when there's no fillers in it, it actually will provide very, very good sound protection, especially when you use the proper trowel that comes with the bucket, a sound control moisture barrier trowel that will lay down that monolithic layer of adhesive, and that is what gives you your sound protection, your sound deadening, basically.
Okay, great. Thank you so much, Sean. So if there aren't any more questions, we've come to the end of the hour. So on behalf of FCICA, thank you so much, Sean and Andreas, for presenting today's webinar. Sims, you may now navigate to the Submit Credit tab to receive credit. Please note that you must be signed into the educational platform for this feature to work. If you have any issues, please let us know. So this is the conclusion of the webinar. Thank you so much for joining us. Thank you, Sean and Andreas, and have a great rest of your day.
Great, thank you.
Thanks, everyone.